This is my molecule, BF3, and yeah, I'll draw the Lewis dot structure of BF3 that I'm holding right here. And basically it'll look like this. The fluorine will have the octet rule figured out in ways such as this. And then the molecular geometry of this molecule is trigonal planar. This is molecular geometry. It'll be trigonal planar, and electron geometry will be also trigonal planar. What's special about this molecule is the fact that boron doesn't have its octet rule structured out, meaning that it doesn't have 8 electrons within it. And it can also undergo the dative covalent bond, the BF3 molecule, when it reacts with species with lone pair. For example, if you were to have F minus here, which has 8 electrons in itself, one of the lone pair here can bond with the boron that is here, which forms where boron acts as one of the electron acceptor, hence Lewis acid, and F, the fluorine minus here, would be electron donor, which means that it is Lewis base in this case.
Okay, that's true. So Lewis acids and Lewis bases, but seeing that it only has 6 valence electrons, you know what a coordinate covalent bond is. Put a double bond between one of the fluorines and the B. What you'd have to do with the valence electrons if you do that?
Right here, we just saw that there's a double bond between boron and fluorine, and the structure is not favored as much as the structure that I draw.
No, but before you say it's not favored, what type of bond, if that bond happened, what would you call that type of bond?
Coordinate covalent.
Okay, so that's a coordinate covalent bond. But how would a chemist decide for any structure that they get where there are 2 alternatives, like this is one here, right, that you have, and the first one that you drew? What method does a chemist use to decide which is the favored structure?
So at first, you know how we had just normal BF3 with no coordinate covalent bond, and we can actually compare the formal charge between this molecule and the first molecule.
Welcome again to CHeM In 3. Today we are continuing from the last lesson where we were looking at the structure of BF3. Now we have Chirag, who is going to explain to us why one structure of BF3 is favored over the next one.
We have two possible structures of BF3, and if you want to determine which one's the most preferred Lewis structure, we use the concept formal charge. So formal charge, number of valence is equal to numbers of valence electron minus number of bonding electrons by 2 minus number of non-bonding electrons by 2. So let's take the first case of this molecule. So let's take on the boron, the central atom. Boron here has valence electrons of 3. So formal charge of boron is 3 minus number of bonding electrons on boron. So 1, 2, 3, 4, 5, 6. So we have minus 6 by 2 minus number of non-bonding. Now there are no non-bonding electron because it's all bonded. So we just say it's 0 because there are no lone pairs on boron. So it's 0. So 3 minus 3 minus 0 is basically 0. Now if we check for fluorine, fluorine will be number of valence electrons. So fluorine has 7 valence electron minus number of bonding electrons. So there's 1, 2 bonding electrons minus number of non-bonding, 1, 2, 3, 4, 5, 6. So there are 6. So you calculate 7 minus 1 minus 6 is equal to 0. So therefore, and the rest, it will be the same on the other two because they are all the same. So that means the formal charge on each of the atom is 0. Like, whereas if we come to this second possible structure, and we can see that the formal charge of the central atom boron in this case will be calculated as 3 minus number of bonding electrons. So 1, 2, 3, 4, 5, 6, 7, 8. 8 because there's an extra double bond here, and minus 0 again because there are no there's no non-bonding electron, so that is -1. Whereas if you check for one of the fluorine atoms, for example this, it will again be 7 because 7 valence electrons in fluorine, minus 2 because 2 bonding electrons, minus 1, 2, 3, 4, 5, 6. 6 non-bonded valence, non-bonding electrons, so that is 0. Whereas if you check, so this, what the formal charge of this will be the same as formal charge of this, but it will be different in this case. There's a double bond. So to calculate that, it will be 7 minus, now there are 1, 2, 3, 4 bonded electrons. So 7 minus 4 by 2 minus 1, 2, 3, 4 non-bonded electron, that is plus 1. So now we have your 3 individual values of formal charge for both the two, both the possible structure. Now we have to decide how to interpret this. And anything that is closest to 0 will be the most preferred structure, and that is formal charge maximum minus formal charge minimum. So we can clearly see that in the first case that here it's 0, 0, 0, whereas minus 1, 0 and plus 1. So this is the most preferred structure, the first one, because the formal charges of each atom are the closest to 0.